Hello guys, how do you deal with this type of question? Okay, if you look at this question here, it's coming from this is coming from product rule. But inside this same question, there is chain rule. So this question is as in it requires a great deal of work. It's something you can just do in two or three lines and just get the answer. But that will be for those who already know some functions. For instance, this cut2s we have here is a function of a function. If you remember what you said about chain rule. So that is why we're not just going to differentiate straight, but we'll first resolve this one and then apply product rule and get the solution. So guys, stick around, follow me, let's deal with this question. Let's go. So if we are taught to differentiate this, remember, this is coming from product rule, so our dy for the s will give us u dv ds plus v du dx. Our u is equals to s squared is equals to cot 2s. So if we apply this rule, it's just a straightforward solution. But the problem we're going to have is when we put the differential of cot 2s, some people will be confused. So a quick one, if you differentiate cot s, you will have minus cosec squared s. So if that is the case now, we apply it to this. But remember, in this question, we are given that one of the functions is cot 2s, which is what we have here. This thing is s. So we can't just differentiate this. This is a function inside a function, so we apply chain rule here. So remember, in our chain rule, we say maybe put u to be 2s, so that if this were to be y, this thing will turn to cot u. So that if you say, for instance, we are doing this inside a function, but we just know what you say y is equals to this is 4. So if y is equals to cot u, it implies that dy du is equals to what? Minus cosec squared u. Also u, we have put u to be 2s, du dx will give us what? 2. So that inside now we can remember that chain rule says that dy ds will give you dy du times du dx. So that means our dy ds inside dy ds here now will give us. So what's our dy du? Minus cosec squared u times du ds, which is 2, which gives us minus 2 cosec squared u. But remember that u is equals to 2s, therefore dy ds will give us minus 2 cosec squared 2s. Take note of this function. We're going to be applying it in the differentiation. So let's go. Let's now solve the problem. So remember that our function, we are given that y is equals to s squared cot 2s. So also, let's also remember that our u here is equals to what? S squared. Our v is equals to cot 2s. So now, having known this now, let's apply our solution. So our dy ds is equals to u dv ds plus v du dx, which gives us, what is our u? We already have our u as s squared times, we differentiate our v. So if we differentiate cot 2s, we already got it before. So we are going to have minus 2 cosec squared 2s plus, so what is our v? Cot 2s times, and if we differentiate s squared, we have what? 2x. This is equals to minus 2s squared cosec squared 2s plus 2s cot 2s. So the y, the x will now give us 2x. If we factor 2s out here, we have 2s into cot 2s minus s cosec squared 2s. This is our final solution. So this is encountering chain rule inside product rule. So guys, I hope you enjoyed this. Follow us for more of this. See you in the next video. Bye.